Welcome to Lesson 26, Part 1 of our interactive notes. So Lesson 26, dividing by one digit using an area model, pages 75 and 76. Okay, so here's our lesson. Our content objective for NBT, numbers and operations, base 10B6. I can find whole number quotients and remainders with up to 4-digit dividends and 1-digit dividers. Also, 4.OA operations, algebraic thinking, A3. I can determine how reasonable my numbers are by using estimation. Language objective. I can use vocabulary related to division to explain how to divide multi-digit numbers. Social objective. I can work with others to create a model to prove the solution to the division problem. Alright, so first, when you do division, we can check to see if your answers are correct or not. And we do that using our inverse operations. So the inverse, that means that it does the exact opposite job. So the inverse of adding is subtracting. The inverse of subtracting is adding. The inverse of multiplying is dividing. The inverse of dividing is multiplying. Use the inverse operation of division and subtraction to check. Multiply the divisor and quotient. So that multiplying undoes the division. And then add the remainder. The adding undoes the subtraction. So here, if we want to check this answer that says that 671 divided into 4 groups equals 167 in each group with a remainder of 3. But to check, you do your divisor, which is 4, times your quotient, which is 167, and then we add the remainder. So 4 times 167 plus 3. So we do our multiplication first, then we add our remainder, and what we have here is our dividend, the number we started with. And if we have that, then it checks our answer is correct. Okay, so now we're going to look at, last lesson we looked at the array, rectangular array to solve. Well, we're going to use a similar setup, but instead of drawing the base 10 blocks, we're just going to use numbers to represent what's going on. So here we practice our estimation. So remember, division has different estimation steps than anything else. We do not round. We look for a compatible number by listing the multiples of your divisor. So 5 are multiples. 5, 10, 15, 20, 25, 30, 35, 40, and you can keep going. Then you look at 2,733. You look at that first digit 2. The digit in the largest place. Is 2 greater than 5? No. So you look at the first 2. If the first digit in the largest place is greater, then you just look at the 1. If not, you look at the first 2. Then you find the number that's closest to it, which in this case is 25. You replace the 27 with 25. We have 2 places after, so we need 2 placeholders. Then we divide by 5. We get 500. This went down, so this is a low estimation. And when our estimation's low, it's a good starting point. Now here we're going to do an area model. Here is our dividend, because that's how many squares would be inside this rectangle. This side is 5, and we have to figure out what this side is. So how many groups of 5 can we get out? We want to try to get out the largest amount of 5s that we can, because division is repeated subtraction, like multiplication is repeated addition. So we want to try to subtract the largest group that we can each time to get down to when we can't subtract any longer. So I'm going to do the 500 because I know that 5 times 500 is 2,500. That is less than this, so I can subtract it. I need to always make sure I have a number less than my dividend. So when I subtract, I get 233. I definitely can take more groups of 5 out of that. So I'm going to bring that up here. And I'm going to multiply by 40 because the placeholder moves it over a place, and 4 times 5 is 2, so I get 200. Subtract, I get 33. I can still take more groups of 5 out of that, so I'm going to bring that up here. Then I multiply 6 times 5 is 30. I subtract, I get 3. I cannot take any groups of 5 out of 3. That 3 is too small, so that will be my remainder. I add these parts together. 500 plus 40 is 540 plus 6 is 546. And then I have a remainder of 3 left over. Then I need to check that. So it is my divisor of 5 times my quotient of 546 plus my remainder of 3. So 546 times 5. 5 times 6 is 30. 5 times 4 is 20 plus 3 is 23. 5 times 5 is 25 plus 2 is 27. And then I add that remainder of 3. So 2,730 plus 3 is 2,733. That matches my dividend, so it checks. It is correct. Okay, we have a couple more examples of what we're doing here. So here, if I'm dividing 756 into groups of 6, well, first I'm going to try to get the largest group I can. If I can multiply by a 10 or 100, I'm going to try that first. So 100 times 6 is 600. If I went for 200 or anything more, it would be too big. This is a large group I can take out, but not larger than my dividend. Then I subtract, I get 156. I can still take groups of 6 out, so I'm going to bring that up here. Now I could, if I didn't know, I could just multiply by 10 and take out groups of 10 sixes or 60 as many times as I can. I'm going to go ahead and do 20 because I can multiply by 2s pretty well, and then the placeholder, that 10 just moves it over a place. So 20 times 6 is 120. Take out those groups, I end up with 36. I can take groups of 6 out of there, so I bring that up here. And I could take 6 times 6 is 36. I can take 36 out of 36 and I'm left with 0. When I get to 0, I'm definitely done. I add these partial quotients together and I get 126. Okay, here's another example. I have 493 that I'm going to divide into 3 equal groups or groups of 3. So I'm going to multiply first by 100 to take a large group out if I can, because 100 times 3 is 300. Subtract out those 300, I'm left with 193. Bring that up here. Now 300 would be too big, so I could try 50, or I could try a number that is easy for me to multiply and keep doing that as I go down. For this example, I went with 60. 6 times 3 is 18. The placeholder moves it over a place. Subtract, I get 13. I can take groups of 3 out of 13, so I'm going to bring that up here. And 4 times 3 is 12. I'm left with 1. Can I take any groups of 3 out of 1? Nope, so I'm done, and that is actually going to be my remainder. I add my partial quotients. I get 164, remainder 1. Okay, now, each of these examples have had 3 boxes. You may have more than 3 to get all the groups out that you need. just make the rectangle as pretty large and just keep going until you get to a number you can't take groups out of. Right. So here, we're going to try one. We're dividing this number into groups of 5 or to 5 equal groups. So my dividend goes inside, and my divisor goes outside. So this side of the rectangle is 5. I need to figure out what the side of this is. I'm going to try a group of 100 because 100 is pretty easy to multiply by, because those two placeholders moves everything over 2 places, and 1 times 5 is 5. So I'm going to subtract out those 100 groups of 5. More on top, no need to stop. More on top, no need to stop. More on top, no need to stop. So I subtract, I get 5, 8, 2. I can definitely take out groups of 5 from that. So I need to take this number, bring it up here. So I could take out more groups. Now 500's too big, so I can't do another 100. But I'm going to try 50 because I'm pretty good at multiplying by 5s. Now if this is too big, then I just change this number. That's also why you do it in pencil, so that if you need to make a change, you can easily. I have to use pen so you can see this more easily, but you always want to do this in pencil. So my placeholder moves it over a place. 5 times 5 is 25. 25 or 250 is less than 285, so I can do that. If I did 60, I would have ended up with 300, and that would be too big. No negative numbers in here. All right, 5. More on top, no need to stop. More on top, no need to stop. Numbers the same, zeros the game. So I get 5 and 3. I can definitely take groups of 5 out of 35, so I'm going to bring that 35 up here. And I know that 7 times 5 is 35. Numbers the same, zeros the game. Can't take any groups of 5 out of 0, so we're done. We add these partial quotients together, so 100 plus 50 is 150, plus 7 is 157. Our next one, our dividend, 968, and our divisor is 7. So first I need a large group, and I'm going to try 100 because that gets me a large group. That's pretty easy to multiply. The 2 placeholders moves it over 1, 2 places, and 1 times 7 is 7. More on top, no need to stop. More on top, no need to stop. More on top, no need to stop. So 8 take away 0 is 8. 6 take away 0 is 6. 9 take away 7 is 2. Can take more groups of 7 out of this, so I'm going to bring that up here. And if I didn't know my multiples of 7 pretty well, I could do just groups of 10. 10 times 7, 10 times 7, because 100's a little big. But I'm going to go ahead and do 30. But if you didn't know 30, you could do 20, you could do 10, something that's easy for you to multiply by. The placeholder moves it over a place. 3 times 7 is 21. More on top, no need to stop. More on top, no need to stop. Numbers the same, zeros a game. I get 58. I'm going to bring that over here because I can take groups of 7 out of it. And then I could do 2 times 7, I could do 5 times 7, anything that I can multiply by, and then I just keep going till I can't take any groups of 7 out anymore. I'm going to do 8 times 7. 8 times 7 is 56. More on top, no need to stop. Numbers the same, 0 is the game. I get 2. Can you take groups of 7 out of 2? Nope, there's not enough, so that is my remainder. So I need to add my partial quotients together. So 100 plus 30 plus 8 gives me 138. And then I have a remainder of 2. So you could do that with a lowercase r or capital R. It doesn't matter which one. That just indicates that there are 2 left over. All right, now let's go ahead and do some more practice with our area model and also with our steps for checking our answer in part 2 with our 3-column notes.